Charles. Back to America, but Bathi is here. Welcome, Bathi, to Delta. Bathi's from Kent State in Ohio, and this is your first Delta, I think? No?
My
fourth Delta, my apologies. Sorry. My brain got fried days ago, so, Over to you, Bathi. Thanks very much.
Well, thank you for staying on to listen to my talk. So I'm from Kent State University, and I work in the mathematical sciences department, but I do teach math and computer science. And some of the courses that are required in computer science are taught by the mathematics department, like many of you had mentioned before. So I'm going to talk about using a platform that is web-based interactive learning in one particular course, Discrete Mathematics. And this Discrete Mathematics has two separate classes that we combine. One is called Discrete Structures in Computer Science, and the other one is called Proofs in Mathematics. There are two slightly different courses, but we teach it together so that we have a critical mass when we teach the class. And most of the students are from computer science, and then the others are from mathematics. So we feel that there has been a paradigm shift in math education with the integration of web-based learning. And in order to understand how changes occur, I think the research that I'm doing is to methodically dissect every layer of influence that the interactive learning brings to the table. And in order to do that, we had to figure out exactly how we are going to measure the performance metrics that these students undergo as they go through the interactive lessons. And to do that, we fortunately, the program in computer science is accredited, and the accrediting agency requires us to go through certain standards that are embedded into the questions throughout the course. And these questions are then tested universally across the board in final exams. And that helped us to kind of get a feel for how the students were doing after they started using web-based interactive learning. And my research also then goes into APOS theory a little bit. We haven't completed the research on this, but we are getting into that. And student survey of instruction was also used to get feedback from students. So just to give you a structure of what the course is, I'm just going to list the topics. This is the first half of the course, and this is where they have an uphill climb. The pinnacle would be the math induction, which they haven't seen. So that would be the most difficult topic for them, starting from logic and then getting into proofs. They seem to be doing okay. They struggle a little bit with sets and functions, and then they struggle a lot with math induction. And then we assure them that the second half of the course is going to be pretty easy. And right now I'm in the second half of the course where we get into counting, probability, graphs, trees, and then finally Boolean algebra. So the web-based interactive learning happens mostly in the first half, where it is needed the most. So the software that we use is called Zybooks, and this is recommended by the computer science department and approved by the math department. And it is used as a supplement, but we also do activities in class using the Zybooks. The Zybooks is, it has interactive modules, web-based. Students do the work on their own. And there are two kinds of activities that they have to complete. One is called the participation activity, which is PA. And then the challenging activities are a little bit more challenging, as the name suggests. And they have to do both kinds in order to complete an assignment. And the assignments line up with the topics that are in the textbook and how we present the topics. The challenge activities are almost like auto-graded homework, but they are divided into stepwise interactive steps. So it's a little bit different. The PAs are very much engaging activities. There's a little bit of reading, then you do a little activity, little bit of reading, do an activity, and they get credit for completing both parts. From the back end, SciBook provides interactive logs that I can go in and check how much time students spent on a task. They get immediate correctness only feedback. And then if they press another little icon, they can get an animated solution. I'll show you an example of that in a minute. And it also refers you to the SciBook text that gives you a little bit of a review of the concept if you miss something. So it's no different than most softwares that you've used, but this one is a little bit more interactive, and that's why we like using this. So here are some sample activities. The first one is from composition of functions, and this is an activity where I can, as an instructor, turn on what is visible to the student and what's not visible to the student. And they have to go through these stepwise solutions in order to get through the composition. And so it's fairly interactive, and if they get one piece incorrect, then they can go back and correct themselves and then keep going until they reach the last part. So this one is considered a challenge activity. Another one, this is a logically equivalent statement where you are given a logical statement at the very top, and you have to start from one side and bring the proof down to the other side. So not only should you know where to start, you can move these little things on the left side into the statement column, and then you can match it with the justification on the other side. So it's fairly algorithmic, and students, of course, make mistakes at the beginning, but then they get used to moving the pieces around, and they find this very helpful when they write their formal proofs in a assessment setting. But this one is considered a participation activity because there's a lot of interaction going on. Here is a feedback loop. As you can see, there's a bunch of animated screens in here, and the students can click each frame, and it'll highlight exactly how the stepwise process works. As I said, induction is a very difficult topic for them. So this tells you exactly what the basis step is, what the inductive step is, and how the proof goes to the K+1 step. This one is considered, again, a participation activity where the feedback comes back to the student. So what methods did we use to analyze the outcomes of using these interactive modules? We went into APOS theory, and I'm not an expert in APOS theory, but our goal was to understand if they can go from the process to the object phase and not even look at the schema side of things. And so the theoretical framework was APOS theory, and the flexibility of the learning modules was certainly in line with small teaching techniques that Lang mentions. And one of the things that most students that I teach in computer science and mathematics have to do, it's kind of like a requirement. They need to engage in 2 high impact practices, especially if they are scholarshiped by the state of Ohio, which is called a Choose Ohio First Scholarship. The two components of the high impact practices would be to do undergraduate research at least once with a professor and to engage in an internship. So we are always looking for students to engage in undergrad research first and then get into an internship. And so while we interview students after they have gone through the interactive lessons, we can then find out exactly what their strengths are and design projects, research projects for them to do. So I have been successful in getting them to do some undergraduate research based off of their interactive learning that they've done in this particular class. Two places where we went into look for the performance indicators was the ABET, which is the Accreditation Board for Engineering and Technology, which accredits our computer science program. And of course, the standard student survey of instruction. We are allowed to put in 3 extra questions, just 3, into the standard student surveys. And so we did that. And the ABET, of course, has their learning objectives matched to performance indicators. And these are given to us. And we have to measure these things against 6 questions that have to be included in the final exam. And so I'm going to share with you a handful of these questions. Here is question number 1, which is on functions. And we have to report back out of however many students we have in our classes, the best response, a medium response, and what they call a worst response. And that has to go into the ABET accreditation system. We have to report it back. And so here is an example of a question where a function has been defined and students are being asked, is this a function or not? And to give an explanation. So this would be considered a best response because the student actually describes the fact that the output is going into Z plus. Whereas this response is considered a middle response. Everything looks good, but the student has not mentioned that the output is positive. So the student won't get the full 10 points in the grading scale, but gets a little bit less. I didn't include the worst response because you can imagine what that can be, right? Question number 2 is a logical statement. I couldn't copy all of the response, but they are supposed to come up with 3 logically equivalent statements to the statement that has been written. If you do well in discrete math and data structures, then you will do well in higher level CS courses. That's the statement. And so they have to come up with the PQ and the R, and the student did that. And here's the one statement, a logical statement that describes the proposition. They have to come up with 2 more, and the other 2 would be the contraposition. The student did that. And then when you do the contraposition, you will have a negation on the right side, which again can be broken down. So that would be the third way of doing it. If you do all 3, then you get the 10 points. The medium response in this one, the student did only 2 of these. And you can also see that the propositions are missing some critical components in there. So the full credit was not given on this one. This is from graph theory. At this point, students have learned how to draw a graph from a table or take a given graph. It can be a directed graph or undirected graph. And they have learned how to look for the cycles in the graph. And they have also learned how to find the optimal solution given weights in the graph. So this question comes in 2 parts. Again, there are 6 questions. I'm just taking only a sample of 3. They have described the cycle. So this student drew the graph correctly, put the weights down, and got the 3 cycles correctly. So gets full credit. Whereas this student got only 2 of the cycles and not the third one, so didn't get the full credit. And the second part of the question is to actually find the optimal solution. And they have to go through the algorithm and find the optimal solution. and label that as the optimal solution. Now, the middle response, the student didn't label the optimal solution, which is pretty obvious here, but didn't label it, so didn't get the full credit. So again, these get reported back to the system. And the second way we checked the interaction with the software system was to insert 3 specific questions into the student survey of instruction. And this was not very helpful because we have only about a 43% return rate. What do I do with this? Hide the video panel, right? Yeah, there you go. We got only 43% typically return rate, and this is from fall of 23 all the way to fall of 24. 257 students in the entire system. So on a Likert scale, all our questions, we have very high ranking on whether the interactive post-learning environment challenged me to think. And then, did you receive appropriate interactive, for the interactive activities, did you receive appropriate help? And did the Zybook activities help you to learn concepts better? Everything was positive. So don't read too much into this because this is not a complete look at things. Whereas this one is measured for every student. These are just again the questions I showed you, Q1, Q2, Q6, A and B. As you can see, the median scores are pretty good. And they did struggle with the identification of graphs a little bit. And then the average scores are listed there as well. So we use this to measure performance, the performance indicators. We also did some grade comparison. I don't have the full details. The reason is that Kent State allows only to go back 3 years. And I have just now got authorization from our institutional research to go back more than 3 years prior to using the software. And we are doing a chi-square test, and the initial results are promising, but we want to have a better baseline in order to compare the grades that we are getting now, and wait for the end of this semester and the end of spring semester to compare how well students are doing. So that thing is forthcoming. Conclusions. We feel that interactive learning tools with less text and more student-focused interactive learning, there is a perfect balance. And discrete mathematics is one of those courses that serves as an inflection point for any of the high-level abstraction courses. And so historically, the DWF rates in the previous slide, as you can see, I have the A, B, C, and we bundle the Ds and the Ws, and W is withdrawals and the failure rates together. And the university has identified this particular course as having moderate DWF rates, and so they have encouraged us to improve. This is one of the reasons why we are trying something different. And other conclusions, we want to create an environment where the students can do well in proof-based courses and engage and thrive in co-creating their learning environment. This study is not complete. As I mentioned before, the chi-square analysis has to be completed once we have enough data to go back and have a couple of more semesters with the system. And then as a follow-up, we just submitted a research grant to Amazon Research Awards. Hopefully we'll get it. And what we're going to do is we are going to advance some of the work that we have done on generative AI with some co-authors. And we want to generate automatic quiz questions with the system will allow us to do that. And so we can go in and program some quiz questions and then also give them feedback that's AI driven through the system. And we want to make sure that that can be done. And of course, analyze the interviews that we've done with the students after their final examinations on these particular questions, the 6 questions, and use APOS theory to understand whether they actually move from process to objective in their understanding. So that's it. I will take some questions. I have some references here, and thank you.
Thanks very much, Bhati. I'll start if that's okay. You said 43% was a low response rate for your evaluations. I'd be jumping over the moon if I got 43%.
Oh, really?
Michael Bulmer can correct me if I'm wrong. Michael's our Director of Teaching and Learning here in School of Maths and Physics, but UQ is down to around 10% standard response rate.
Oh,
and
so I
they
should be happy
changed
about
the
it.
system, I think, from this semester or from the start of the year. They changed the system to try and increase that response rate from the students. But gee, I haven't got 43% for about 15 years.
That's good to know.
Michael,
yeah, we have it all online.
Ours are all online too, but hey, I got one student to 5 lectures this semester. So did you want to? Oh, okay. So we're back up to 40%. Right. Any other comments or questions for Bhati? Paul?
Thanks. I wanted to ask about the feedback they got in the interactive activities.
Yeah.
Did they get anything apart from whether it was correct or incorrect? Or
yes, I can turn on the option so that even if they get it correct, they can go back and look at the stepwise solution. Yeah.
did you give like comments or something about like what common errors might be and things like that?
Yes. So the functions, set theory, and induction. Those are the ones that they find very difficult to do. So there's one day during the semester where they walk in. So we have a room where there's enough board space, whiteboard space, and chalkboard space. Before they come in, questions are written, especially with math induction. And I put them in pairs. We have smaller classes, no more than 20 or 25 students. And they work in pairs and then do a think, pair, share type thing where they write the solutions on the boards. And that's all they do for the whole day. And then we take photographs and convert that to posters and display it outside so that they get ownership of what they've done. And with very little interaction, they do very well. And that activity is facilitated well by what they do online.
Any other questions for Bhati? Well, we look forward, Bhati, to learning about your grant, hopefully, from Amazon and the work once you get those grades going back some years. So all the best for your future research, and thanks for coming all the way to Delta. Thank you.
Thanks for having me.